Hey there guys, welcome to Unit 5 Notes B. In Notes B we're going to talk about percent composition. So percent composition is actually something you should be pretty familiar with if you know how to calculate percentages. It'll be really easy. So something you guys always calculate, how did I do on that test? So in order to figure that out, you would put how many you got right, divided by how many questions there were, and that would give you a percentage, which is kind of based out of 100. So it's the total of what you're interested in. In this case, it'll be the mass of an atom, divided by the total, in this case, would be the mass of the entire molecule. So let's kind of get into this. It is all about mass percent. Another thing I want to mention about percentages, you want to round your percentages to the tenths place. So that's because you're always estimating one past. You've got your known value and you're estimating one past. So if you think about a percentage, it's part of a whole. So one estimation past the whole would be the tenths place. So with your molar masses, you're rounding them to 2 decimal places, and with your percentages, you're rounding them to 1 decimal place. So at least it's something concrete, right? All right, let's calculate the percent composition or mass percentage of C3H8. So I'm going to start setting this up very similar to the way that I did for molar mass. I'm going to count how many carbons. In this case, there would be 3. And I'm going to count how many hydrogens. In this case, there would be 8. Then I'm going to multiply that by the molar mass of each. So carbon's molar mass on the periodic table is 12.01 and hydrogen's is 1.01. Then I'm going to multiply, and I need these subtotals. So when we were doing molar mass, it didn't really matter how you were adding this up. This time we need the subtotals. So 3 times 12.01 is 36.03, and 8 times 1.01 is 8.08. You do still want to add them up. We need the total mass. So if we add up 36.03 and 8.08, we get, where'd it go? Some 44, I think. Yeah, 44.11. Back out of that. So I've got my subtotal of carbon, 36, my subtotal for hydrogen, the 8, and then the total molar mass, 44.1. So let's say I want to find the percent of carbon. I'm going to take my 36.06, the part that's carbon, and I'm going to divide that by the total, the 44.11. The part of the carbon divided by the entire molecule. And then what do you do for any percentage? Multiply that by 100. Then we're going to do the same thing for the hydrogen. We take the part that's hydrogen, the 8.08, and divide that by the entire molecule, 44.11, and then multiply that by 100. So that's going to give you the percentage carbon and the percentage hydrogen. When you calculate mass percent, you have to do it for every single atom in the molecule. Even if it were an ionic compound, you would still break down the ion. Do it per atom. Molar mass is always percent composition or mass percentage is always per atom. So that would give us 81.7. Notice it's to 1 decimal place for the carbon, and 18.3 for the percentage of hydrogen. Notice that these two things would add up to 100. So I get the question sometimes, well, couldn't I just solve for one and then subtract from 100 in order to get the other? And you could, but you better hope that you were right on the first one. I would prefer to do it twice and then make sure that these two things add up to 100. Keep in mind that we are rounding to have 1 decimal place, so if you end up with 99.9 or 100.1, that is okay. We just want to make sure that they're roughly adding up to 100 since they are percentages or parts of the whole. So this gives you the amount of carbon and the amount of hydrogen in the entire atom based on mass. Notice it's very different from the atom count. It kind of looks like the molecule has a lot of hydrogen, but because hydrogen is such a small molar mass, it actually makes up a much smaller percentage of the molecule. So this is how we account for that. We've just got to get the part divided by the whole. All right, that's it for percent, guys. Pretty easy. The next notes that you're looking for are note C, which will be all about hydrates.